Hey guys, in this video we will be going over how to solve radical equations. Radical equations contain a variable in the radicand, and the following are examples of radical equations. Let's focus our attention on square root radicals for now. If we square a square root expression like the square root of 3 or the square root of x, this will just equal the inside of the square root. Therefore, squaring a square root expression eliminates the radical, and we are just left with the radicand. So to solve square root equations, we rely on a property known as the squaring property of equality. So if a is equal to b, then a squared is the same as b squared. Unfortunately, this squaring property does not guarantee that all solutions of the new equation are solutions of the original equation. For example, if we have x equals 2, and if we square both sides of the equation, we have x squared equals 4. This new equation will actually have two solutions for x. X can either be 2 or negative 2, while the original equation only has one solution, which is 2. And for this reason, we must always check the proposed solutions of radical equations in the original equation. We call negative 2 an extraneous solution, which is a value that satisfies one of the new equations but does not satisfy the original equation. So let's write down the procedure of how we will solve radical equations containing square roots. The first step will be to get a radical on one side by itself. And then the next step would be to square both sides of the equation to eliminate a radical. Then we combine like terms on each side of the equation. And if the equation still contains a radical, just repeat steps 1 to 3. Otherwise, the next step would be to solve the equation. And then the last step would be to check the proposed solutions in the original equation and discard extraneous solutions. So let's try some examples. For this equation, we already have a radical on one side by itself, so the next step is to square both sides of the equation. For the left side, since we are squaring a square root expression, we know that this will eliminate the radical, and we are just left with the radicand. So the left side simplifies to x minus 2. The right side simplifies to 3 squared, which is 9. And now we can just solve this new equation for x. This will give us x equals 11. We will need to check this proposed solution in our original equation to be sure that it is not an extraneous solution. So checking our solution, this gives us a true statement, therefore 11 is our solution. For the next equation, we need to first get the radical by itself on one side. So we subtract 6 from both sides of the equation. And now we can square both sides. This will eliminate the radical on the left side. And the right side simplifies to negative 6 quantity squared, which is positive 36. And now we can solve the equation for x. We get x equals 31. Again, we need to check this proposed solution in the original equation. However, checking this value gives us a false statement, meaning that this is an extraneous solution. We then say that the equation has no real solutions. For this equation, we first need to get the radical on one side by itself. So we subtract 1 from both sides of the equation. Now we square both sides, and make sure to square the entire right side. The radical on the left side gets eliminated, which leaves us with 2x plus 1. And on the right side, this time we are squaring a binomial, so we will have to expand this out to multiply. So we have x squared minus 2x plus 1 on the right side. And now we have to solve this equation. This time we have a quadratic equation since we have a degree of 2. And to solve the quadratic equation, we will need to get it in standard form first, and then factor the right side and use the zero factor property. This gives us x equals 0 or x equals 4. Now we have to check these proposed solutions in the original equation. X equals 0 gives us a false statement, therefore this is an extraneous solution. And x equals 4 gives us a true statement. Therefore, this will be the solution to our original equation. Okay, so now let's try some examples of equations containing two square roots. We begin by getting a radical on one side by itself. So let's add 3 square root x minus 5 to both sides of the equation. Now that we have a radical on one side by itself, we can square both sides. This eliminates the radical on the left side. And be sure to use the power of a product rule on the right side to raise each factor by 2. So we get 9 times x minus 5 on the right side. And now we solve this equation for x. We get x equals 7. So check this solution in the original equation, and we get a true statement. Therefore, 7 is our solution to the original equation. For the next equation, we first need to get a radical on one side by itself. It doesn't matter which one we isolate, but it may be easier to isolate this radical. So we subtract square root x from both sides. And now we have a radical isolated on one side. We can square both sides of the equation, and this eliminates the radical on the left side, so we have x plus 5. But on the right side, to square this binomial, we will need to expand it out and then multiply. Combine the like radicals, and then we get 25 minus 10 square root x plus x on the right side. The resulting equation still contains a radical, so we will have to repeat our steps for solving square root equations. We will again need to get the radical on one side by itself. So subtract x from each side, and then subtract 25 from each side. Now we could square both sides of the equation from here, or if it's easier, we can divide both sides by -10, square both sides again, and we get x equals 4. Now we check this solution in the original equation, and we get a true statement. Therefore, 4 is the solution to the original equation. For the next equation, we need to get the radical by itself on one side. Again, it doesn't matter which one, so let's isolate this one. Add both sides of the equation by the square root of 4x plus 1. And now that we have a radical isolated, we can square both sides. The radical eliminates on the left side. However, we will need to be careful with the right side. Expand out the binomial and multiply. Combine the like radicals and the like terms. Then the right side simplifies to 2 plus 2 square root 4x plus 1 plus 4x. Since the resulting equation still contains a radical, we will have to repeat our steps again. We will need to get the radical on one side by itself, so let's subtract 4x and subtract 2 from both sides. Now that the radical is on one side by itself, from here we can square both sides of the equation, or we can first divide both sides by 2. But for the purposes of avoiding fractions, we'll just square from here. So expand the left side and multiply. This simplifies to x squared plus 8x plus 16. And the right side simplifies to 4 times 4x plus 1. Now all that's left to do is to solve the resulting quadratic equation. We get x equals 2 or x equals 6. And I'll leave it up to you to check these proposed solutions in the original equation, but both will give us a true statement once checked. Therefore, 2 and 6 are both solutions to the original equation. We can solve many equations with radicals of different powers. For cube roots, the steps for solving are all the same, except in order to eliminate the cube root, you would instead cube both sides of the equation. We eliminate radicals by raising the expression to whatever the index is. So for this example, begin with getting the radical on one side of the equation. So we add 2 cube root x minus 1 to both sides. Now we cube both sides of the equation, and this will eliminate the radicals. So we have 7x plus 1 equals 8 times x minus 1 as a resulting equation. And now we can just solve this for x, and we get x equals 9. Checking this in the original equation will give us a true statement. Therefore, 9 is a solution to the original equation.